Alright, now let's solder the charging port back on. We're using this mini heating station to solder the charging port. The advantage of a small heating station like this is that it's compact, easy to handle, heats up quickly, and offers a wide range of temperature settings. Setting it to around 230 to 250 degrees is more than enough for installing the charging port. After setting the temperature, we can hold a tool in each hand. This makes it much easier to secure the flex cable while positioning the charging port at the same time. Because the charging port is covered by a metal shield, we can't actually see whether the solder underneath has fully melted and bonded, so we have to rely on feel and experience. Once the solder on the outside starts to melt and you see that slight reflective shine, that usually means it's ready. Since the solder pads on this charging port need to be perfectly aligned, I made a small opening on the aligning point using a grinding tool. This gives us a clearer visual reference and makes it much easier to line everything up accurately. These two alignment points are used to line up the flex cable during soldering. On the right side, there's no opening, so it's much harder to see the pad underneath. The charging port should be good now. Alright, let's put everything back together and test the device. So, what do you think? Did we fix the problem? The charging power still isn't going up. So, what would you do at this point? For me, I'm starting to think it might be the other USB charging chip, the SN2610. Ayo, that's failing. For us repair guys who really love what we do. The best approach is simple. Just go ahead and replace the chip first and deal with the rest afterward. In the end, I thought about it again. Usually, when the USB charging chip fails, the boot current will leak or behave abnormally. But from the very beginning, we already saw that the boot current was normal, with no leakage at all. So, after calming down and thinking it through, I started wondering if the EEPROM chip might not be seated properly, or if something else is going on there. Later on, after checking online, I realized that the chip I replaced wasn't even the EEPROM chip. That was unfortunate. And this is the one. Mistakes like this, as repair technicians, doesn't it feel strangely familiar? We've all been there. Alright, now we're going to remove the full set of components from this dyno board. Since this chip comes as part of a matched set, we have to take it from the previous donor board, retin it, and then install it again. let's put it back together and test it again. At this point, I'm praying this thing finally charges. Otherwise, I'm going to lose my mind. The moment of miracle has finally arrived. The problem is finally solved. Alright, let's put the metal shield back on and get the device assembled. We'll also clean off the excess solder paste on the metal shield using a wick. Apple's motherboard design is extremely precise, so any extra solder can easily touch nearby chips and cause a short, which could burn the board. So we need to be extra careful here. Here we shouldn't use high temperature. Around 250 degrees is enough. This helps prevent blowing out the underfill power chip next to it. Alright, let's put the motherboard back into the back housing and test it again. Alright, the device is fully repaired. We can go ahead and assemble everything and seal it up. Sorry for the long video. I could have edited it down and removed all the mistakes. But I feel that our thought process during a repair is really important. And honestly, mistakes are part of how we grow as repair technicians. So I think it's worth keeping everything in so everyone can learn from it and avoid taking the same wrong turns. That's all for today's video. Hope you found it helpful. Every small detail makes a big difference in repair work. Thanks for watching, and don't forget to subscribe for more tech repair tutorials.